So welcome everyone. This is Introduction to R, one of my favorite topics. I think all of you got the handouts. There's 2 handouts. Okay. So the main handout that we're going to be doing is this one called Introduction to R. And what you'll notice is that on the page 2 and 3, we have a nice little table of contents. So if you need to flip to something real quick, that will help you find out what page to go to. Also, if you turn to the very back, actually page 128, I guess not the very back, there's an index. So on page 128, there's an index of R terms. So it's a nice place to look if you're trying to remember, well, what does a class mean in R's terminology? What does an object mean in R's terminology? Well, there's the page reference where I first give it to you. And then on page 129, we have another index that shows the various R functions that we're going to be looking at. These R functions perform our calculations. And so this is a nice summary of where everything is that we're going to be discussing. And again, the first time that the function's used, that's the page number that's listed there. At times, there's the functions are used maybe in a little bit different way, so I also give you a different page number too. Okay. So that's the first handout. And I anticipate, or maybe I should say I hope, that we get through section 5, which is on logistic regression. And it will be nice if we get to additional topics too. Section 6, we'll just have to see. If we don't, think of this as a bonus, and you can read it on your own. Then the second handout is this extra information on R. Just little other bits of information like web resources that are good, the history of how R came about, and so on. And so we will periodically refer to this, I guess you could say take a break from the main set of notes. Okay. So then during this workshop, I plan to at times stop to give you an opportunity to try some stuff on your own. But if you want to try stuff that I'm doing at the same time up here, please feel free to do so. Also, if you have any questions, of course, feel free to interrupt me. So this is, I guess, a rough schedule of what I'm thinking. So we're going to go into about 10 a.m. or so and then take a short break. Now, does everyone have R version 2.13.1 on your computer?
Yes, indeed.
Okay. So why don't you open it up? Why don't you do 32? Also, does everyone have TinR on their computer version 1.17.2.4? Oh, such a long version number.
It's going to help if you go help about.
Yeah, it should look like this. If you do help about. So Jim, you have the newer one? Okay, so when we get to that, I'll give you some background about how you can still use it. Does anyone else have the new one versus the old one? Real briefly, there's 2 ways that you can use R. And it's easier for new users to use one way, which uses this version of TIN, versus the other way, which the new TIN uses.
I'm trying to open TIN up. It says Windows can't open this file.
Are we working in TinR?
Yes.
This is the short
like 2 months advance notice to download.
This is typical, by the way.
Alright.
Is yours said, John, you said?
I'm downloading. Yeah.
So you said those to.
Chris, which files do we download?
There's one at the very bottom of the web. Are you talking about the TINR files? Okay, let me go there. It's at the bottom of the page. It's the one that says setup for TINR.
Mark, you good? Okay. You guys, is it?
No.
Just that?
Where do I find this? Oh, in your programs.
No,
No,
it's
no.
it's all good. It's really easy. In our area. Is that what you're looking for?
There should have been an
R should have been
Right.
on the desktop.
No, Chris, I'm actually looking for your program. I have TINR, but I don't have your program
Okay,
files.
so go back.
Okay.
Is that on chrisbuilder.com?
Yeah, so if you go to chrisbuilder.com/workshop, or this is the actual physical address, if you can see that, you can download the zip file, and it has everything.
What is this run? Just go back.
Larry's just computer genius on one. I'm like,
Okay. Click on that download R2.1.3.1. Workshop files.zip.
Yep.
You want to run or stay? Run.
What are you downloading now?
Yeah. I'm downloading zip files.
For this?
Yeah, I had TINR, but I didn't download the actual files.
Those.
That one at the top there where it says, yeah.
For,
Sorry, maybe I should have said that beforehand. I thought, I'll do this real slick instead of having to tell every single person who walks in. I'll put a little sign up there, or there was a sign up there that said what to do. But sorry, I should have
No.
brought that up instead of just sitting here waiting for us to go.
Maybe give you an icon on your desk. Okay, cool. Yeah, I'm good now.
We wouldn't listen anyway. So. Files is-
that's what all I know.
Not yet. So if you double click on any of those files,
Yes, I
these
got it.
files, it's like fire.
Okay, are we set? Okay, we're good.
Yes, sir.
Okay, so just to help me out, then I'm just curious about all of your R experiences. Have any of you before this downloaded R and installed it and maybe played around with it?
Well, I guess that's 3 of us.
Okay, so that's okay. I mean, I was expecting that. I just wanted to make sure.
Those should be a TS.
What's that?
The TA. Mark and Larry. Deputized.
So I guess to give you a little bit about my background with R, I started using S+, which is somewhat similar to R, I should say, probably in the mid-1990s when I was in grad school. R itself, the first full release to the public came out in 2000. And I first heard about it in 2001, and since I was already an S+ user, I had heard it was very similar, I decided to take a look at R, because after all, it's free. And I thought, oh yeah, this is pretty good. There was some stuff that they still needed to work on to make it good enough to replace S+, and shortly they did. And so probably about 2003, 2004, I stopped using S+, started using R. And in fact, also I was primarily actually a SAS user when I was in grad school and began my career as a professor. And I've stopped pretty much using SAS too. I do all my research, all my teaching with R. And as I like to tell my students at Nebraska, that R has revolutionized how we do statistics. And hopefully, after today, you'll see why that is true. Okay. So let's begin on page 4 then. We won't use tin for a little bit, so you don't need to have tin immediately open, but once you just open up R.
You mean the actual page number?
Yeah.
Yeah, sorry. So this is what R looks like when it's open. You have this scary thing right here. Absolutely no warranty. I don't know if that prevents new users from starting to use R. But we'll talk about issues about, this obviously is open source. We'll talk about issues regarding that later on. And is this big enough in the back so that you guys can see it? Okay. So you see this is the R console window. This is where you can simply type commands. And at the bottom left there, you see a command prompt. And so if you look at page 5 then, we can try some very simple examples. You can use basically the R console window if you really wanted to as a calculator. So if I type 2 plus 2, you can go ahead and try that too. Well, you get what you would expect, 4. So I guess there's nothing to worry about with R and it being open source. And you can try some other just simple calculations on your own. What would be intuitive? Like for example, if you did 1/2, you would expect 1 divided by 2, and that's what happens. If you do 2 times 2, of course you get 4 as well. You can also try some other commands. Like for example, if you did log of 1, that would be a natural log, and you get 0.
Does pi to 6 digits.
Excuse me?
Does pi to 6 digits.
Yeah, that's right. So there's pi. So if you just simply type pi, you get what you would expect. Also, there's some other cool things too. If I type pnorm, what do you think that stands for? Pnorm.
Normal probability.
Yeah, normal probability. And if I put if I put 1.96 in parentheses, I get 0.975 back. And in fact, I don't know if any of you still use like normal distribution tables or t-distribution tables. Well, this kind of, since it's so easy to get those kinds of things out, I don't even use those anymore. I haven't for a long time. So you can see you can use this R console window basically as a calculator. Now, at times you might want to save some results so that maybe you could use those results later. So some calculated results. So to do that, what I like you to type is the word save, and then the less than dash, a less than sign, and then a dash, and do 2 plus 2 again. Now notice that less than dash there kind of looks like an arrow going to the left. So basically what this is saying is what's on the right-hand side of 2 plus 2 is going to go into something we called save. I could have called it a different name if I really wanted to. I just chose save. And so if you hit enter, notice nothing comes back to your screen. That's because it's in save. So if I type save, there you go.
So you have the arrow doing it. The word save.
Save is the name.
Yeah,
Save is just the name.
yeah. I could have called it something else.
Could always call others.
So you have to though type whatever you want to save, you have to type the whole thing after that arrow?
Well, if you are doing some kind of calculation, that's what goes on the right-hand side of the arrow.
Right.
So like, for example, if I want to estimate a linear regression model, which we will do later, I put some code on the right-hand side to do that, and then I save it into something like called save. Okay?
So it's a good idea to do that save before whatever you're doing so that it automatically just keeps saving, right?
To some respect, yes. It depends upon if you want to save it or not. I mean, if I was doing the pnorm function, I might not want to save it. I just maybe want it quickly. It just depends upon if you want to save it for later, for some purpose.
So, for example, right now, did you type that in saying you have to save? So type in save plus 4.
So if I would type save plus 4 like that, and then do a less than dash or just that. Yeah, okay, I see what you mean, yeah. So notice what happens. Save has the numerical value of 4, and if,
Add or
yeah, yep. So if I did maybe,
It's like a memory thing. Calculator.
yeah.
yeah.
Right.
Yeah. And so let's talk about some R terminology then. This save is in R's terminology called an object. So I have created an object to save something in for future use. This less than dash part there, what that is referred to in R's terminology is I'm making an assignment. I am creating an object called save, and I am assigning the number or the results from 2 plus 2 into it. So object assignment. One more bit of terminology. That less than dash, the way that's often verbalized is as the word gets, G-E-T-S. So our user would say save gets the results from 2 plus 2. Now, I know most of you are not SAS users, but we at least have one SAS user here. Let me relate something to SAS here. Now, in SAS, there's something called basically a work library. And you can think of the work library in R as where we just put this thing called save. And the way that you can see the work library is there's two ways. One is to type ls parentheses m parentheses, which stands for basically list. And notice there's something called save inside of it. Alternatively, you can type the word objects parentheses m parentheses, and save is in there.
I did ls, and I'm getting oh.
So
Yeah.
list and objects is the same thing?
I'm sorry, say that again?
List and objects is the same
Yes,
thing?
that is correct. Yeah. If you're familiar with Unix, you know that like a Unix command prompt, if you want to see a directory structure, you would type ls, and that's where this is coming from. But obviously, objects make sense because this is what it is, or that's what these are. They're called objects. Now, let's see. When you exit R, you don't need to do this. I'm just going to show you real fast to show you what happens. It says save workspace image. And what that allows you to do is if you want to save the stuff that would be in your what's actually called a workspace, or like the SAS work library, it will save it for you if you hit yes. If you hit no, it's not going to remember what you've just done in terms of what's in the workspace. I usually hit no because the stuff that I do is going to be able to be recreated anyway through a program that I am writing. So I don't need to actually save the results for future use. So let me just hit cancel out of there.
Save the objects or that action?
It saves the object. So it would save the thing called save with the value of 4 so that the next time you open up R, it will still be there. Now, the way that R does its calculations, like what we saw for pnorm there, is to use what are called functions. So pnorm is a function. And to give you a quick experience with writing a function itself, let's write a function that calculates a standard deviation. So the first thing I need to do is tell R, well, what's my data that I'm going to actually calculate a standard deviation of. And you can do this with me if you want to, or you can just watch. It's up to you. And so first of all, I need to create an object that has my data. So how about if I say x gets, and then what I would like to do is have a very simple data set that has 1, 2, 3, 4, 5 in it. And basically, I need to combine those numbers. So I use the C function. So I'm combining them into one data set. And I'm putting that information then into X. So that if I hit enter and type X, you see 1, 2, 3, 4, 5. Now let's write a function that calculates a standard deviation. There is already a function called SD for standard deviation, and so I don't duplicate it here. I'm just going to call it SD2. So I say SD2 gets, so SD2 is actually going to be an object as well. Function, numbers in parentheses, So this is just R's way of saying, or our way of telling R, I'm going to write a function. And if you're familiar with like C, Fortran, or other kinds of programming languages like that, there are things called like procedures, or also called functions, where basically you write it in a general manner so you can pass information into the function and a calculation's done. And so the information that I'm going to pass into the function, something I just decided to call numbers. And also I'm going to use a left squiggly bracket there as well. That tells R, okay, now I'm going to start typing the contents of what's inside my function. And when I hit enter, notice what R does. It gives me a plus sign. It says, okay, you need more. You need to tell me more about what's inside your function. So, a very quick way to calculate a standard deviation would be to take the square root of the variance. Perhaps this is cheating a little bit. So there's an sqrt function for square root. There's a var function for variance. And whatever I pass in for numbers is what's going to be used to calculate the variance and then the square root.
Did you mean to say n numbers, or is that a
Oh, no.
typo?
That's a typo. Thank you. So if I hit enter there, notice I still have a plus sign. So it says, okay, I'm still waiting. Tell me more. Well, I'm actually done typing my function, so I use a right then bracket and hit enter, and now I'm back to the command prompt. So if I typed SD2, notice you see the actual function. If I typed ls, parentheses and parentheses, notice what we see there. We see save, SD2, and x. All of them are objects. So lastly then, if I want to actually run this function, I say SD2 parentheses x and parentheses. So x is going to go into this function and basically replace numbers. And if I hit enter, there's my standard deviation.
I gave that up years.
And if you want to save it, you could have done that again.
Exactly. So I could have said save, let's say call it save 1, SD2, x, and if I did save 1, there you go. So this is one of the nice things that people like about R is that you can customize it to satisfy your needs. Write your own function that does something. Maybe combines the results of other functions that are already built in R. And so this is one of the things that people like about R, and we'll see ways that people have customized R to satisfy their needs and also to satisfy other people's needs. Now, one of the key things to realize that when you're working with a function is that the last line that's in the body of the function, in this case there's only one line, but whatever's the last line, that's what gets returned to the user. So when I actually did type SD2 parentheses x and parentheses, what was returned to us was this numerical value. So what would happen if I, let's say, had more than one line in it, just to show you that indeed the last line gets returned. And I'm just going to copy and paste some code real quick to make this easier. Okay. So this is what my function is going to look like, where I'm just going to add one additional line that's above the square root part. I'm going to have the cat function, and the cat function allows me to print information. So I'm going to say cat parentheses, print the data. The /n is a fancy way to say R, go to the next line. Then I'm going to say print whatever's in numbers. And then /n, go to the next line. And if I do that, oops, well, that's not good. Let me try it again. Actually, let me just copy it from here. Oops. Give me a second. And so now I have the SD2 that looks like this. So if I say SD2x, you can see see what happened, print the data, and what's still returned to the user was what was in the last line. If I were to say save gets SD2X, notice you don't see that 1.58 anymore because that's what's going into something called save. Okay? So that's just a very basic first hands-on exposure to functions. Are there any questions? Okay. Well, you might need to get help about how to use R. So, what kind of help facility does R give you? So what I would like you to do in R, click on Help. And you see a variety of things that are shown there for help options. We're going to go to the one called HTML Help. And what's going to happen is in your browser, you get to basically the main help for R. Okay. Now, the first things that you see there are manuals. Yeah, so there are free basically books available to you to learn how to use R. So one of the first ones that you would want to look at is an introduction to R. For the reference area, see a search engine and keywords. Well, that allows you to, let's say if I want to figure out how do I do regression, well, you can type it into search engine and R will come up, or the help will come up with the corresponding function that's used. What we're going to look at is packages here. So why don't you click on packages. And yours might look a little bit different from mine because I've been using mine for a while. But basically, if you page down, you see a bunch of what are called packages. And again, to make a SAS reference, SAS is broken up into components like base, graph, stat, OR, and so on. Well, R is broken up into components called packages. All functions that come installed in R, meaning that you didn't write the function yourself, all functions are within a package. So, for example, if you take a look at this package called stats, that allows us to do some very basic statistics, functions involved with that. So why don't you click on stats. And let's find the help for pnorm that we used earlier to find a probability from a standard normal distribution. So let's see. There it is. So there's pnorm. Is everyone there? Okay. Why don't you click on that, and here is the help web page then for pnorm. This web page gives you a variety of things, and probably like most software packages, it's going to be a little bit difficult for new users to fully understand all the components of it, but you can see the general structure for a help web page, a description of what it does, usage. Notice there's not just the pnorm function there. Is that big enough so you can see it? Okay. It's not just the pnorm function there, but there's also something called the dnorm function, which evaluates the density function for a normal distribution. In other words, like little f of x. Qnorm finds a quantile from a normal distribution. And rnorm, what do you think that does? Any ideas? R stands for random. Suppose you want to randomly simulate some data from a normal distribution. Well, we have an rnorm function for that. And we see a bunch of other information, some details. And at the very bottom, probably this is the most important thing for you to see right now, is that you have a whole bunch of examples. You can copy and paste these examples into R and run them. And that's very helpful to determine, well, how does this function work? But what I want to focus on is this pnorm function. So you see some stuff that's within the parentheses. The first thing you see is Q. Q stands for quantile. So before, when we were running pnorm, we were putting 1.96, if you remember, in pnorm. Well, that was basically a quantile, or you could also say a percentile, from a normal distribution. And then what we got back, let me just execute that again real fast. Oops, sorry. Pnorm, sorry. What we got back was the probability. So 1.96 is the 0.975 quantile from a standard normal distribution. If I wanted to, oops, I'm having problems typing today. If I wanted to, I could have said this instead. Pnorm parentheses Q equal 1.96. So it allows me to specify what, in R's terminology, allows me to specify the argument name, that is, Q. The argument value is 1.96. Okay, so if I hit enter, of course I get exactly the same thing. Now if I go back to the help, you notice there's some other arguments in there as well. Mean equals 0, SD for standard deviation equals 1. So notice these argument names have default values associated with them. So by default, R works with a standard normal distribution. Oops. So if I come back over here and type mean equals 0, SD equal 1 real quickly there, I get exactly the same thing back. Also, if I would do this, suppose I remove the argument names, I get exactly the same thing. The key is you have to understand or know the order of the arguments. But let me warn you, well, let me give you some advice. I recommend always using the argument names. That way, there's going to be no chance for error. I strongly recommend that. What you'll see other R users do more predominantly is that they will actually leave off the argument names. But trust me, from experience, it's always good to put the argument names there.
Can you shift the order if you have the argument name?
Yes, you can. Yes, you can. And that's a nice convenience then. Okay. Now, what I like you to do is pick out your favorite distribution. I hope all of you have favorite distributions. Pick out your favorite distribution and find a probability associated with it. So you can go back here. And in the stats package, I'll actually give you a little bit of help. If you page down to see this also in the help file, you see a link to distributions. Right before, yeah, it's towards the bottom. This is the quick way to find these other probability distribution functions. We could also go through the same process that we did with the pnorm function to find that. So if you click on distributions, you see a whole bunch of different distributions. So why don't you take a few minutes, just pick your favorite distribution, see if you can figure out how to find a probability associated with it. The key thing is you're always going to see the letter P and then some kind of abbreviation for the distribution. So for example, notice you see d beta. Well, there's also a p beta function that allows you to find a probability with a beta distribution. And there's corresponding parameters with the distribution that you'll need to specify. So why don't you just take a minute or two to find that, and if you have questions, ask. Yes?
Oh, I'm sorry, smaller question.
Okay. There's stats. You have to go to stats first.
That's what it is.
The function lives in the stats package.
Oh,
Okay, so we pick a distribution and then what?
I find a probability with it. Now, of course, you'll need to specify perhaps parameter values, or you can go with whatever the default is. You know, like what we originally did with the pnorm function. There are actually more distributions out there, but they're in other packages. These are just given to you by default when you install R. So are we having success? Does anyone need any help? I'll be happy to come to your computer. Well, you could just type it in if you wanted to, or you can copy and paste a segment of it. So I guess just to give you another example, suppose I was working with then the beta distribution. I could just, let's say, copy and paste the required arguments and also the function name. So Q, shape 1, shape 2. So if you're familiar with the beta distribution, there's usually an alpha parameter, there's a beta parameter. If I just copy, paste it over here, then I can just use my arrow to do this. So P beta, Q, the quantile, the 0.5 quantile. Remember, beta is between 0 and 1. Shape 1 equal 1, shape 2 equal 1. Does anyone know by chance another name for that distribution? Or am I getting too academic? It's uniform.
And just real quick so they can see it, what you just did there,
Yeah?
get rid of that line again.
Okay, yeah, thank you.
So let's say you just ran that and you went, oh, wait, I didn't want to do it to 0.5, I wanted to change that to 0.25.
Yeah.
Instead of retyping the whole thing? Or did
Yeah.
you just repopulate?
Thank you very much for bringing that up. If you wanted to access the previous line of code or even previous lines of code, just use the up arrow. And you can also use the down arrow to cycle back.
That was cool. Did you guys get that? That's an important thing that you showed.
Yeah. Sorry. I should have brought this up. In the end, typically what you do is you write your own program, so you're not needing that. But if you hit the up arrow, look what happens. I cycle back through what I've been typing. If I hit the down arrow, I can cycle the other way. So it's a great way to go back and forth.
What, my help thing
Yeah.
just goes away when I come to this one.
Well, they're two separate windows.
Yeah.
One's an internet. One might be like, for example, Internet Explorer. One might be in R, or one will be R, I should say. And so when you, let's say, copy something from Internet Explorer, go over to R. Yeah, and they don't live in the same window structure. This is totally outside of R, the actual help.
That's
Okay.
I have both open, but I just have to create two.
Yeah. So what was a distribution that maybe one of you picked? Chi-square. So probably was P chi SQ, parentheses. Let's say maybe 3.84 degrees of freedom. Well, you could just put 1 there, but the actual name is df equal 1, and parentheses, get 0.95. So the 0.95 quantile from a chi-square 1 is 3.84. Okay. So we okay? Can we move forward then? Okay. No? I guess in the notes we're about page 13.
So it gives me a 0.682, so my quantile was 1 and df was 1.
So were you doing P chi SQ parentheses and then what?
Q equals 1,
Q.
df equals 1.
Degrees of freedom equal 1? Yeah, that seems reasonable.
That's what I got.
You don't need to duplicate what I'm going to do here because we'll look at it later. Let me show you a plot real fast. Of course, I'm having problems typing too. Let's see.
So you have to remember all this?
You don't have to remember. You can make it a heck of a lot easier. Hang on to this right here.
That's right.
Or open the, what's here?
So there's a chi-square 1. And so when you did oops, for some reason that went off my screen. There's a chi-square 1. So you can see that it makes sense to have 0.68, I think you had for the probability. It makes sense. And we'll look at this function called curve in a little bit. Basically allows you to graph any kind of mathematical function of one variable. Now, so there was a question about, well, so do you have to remember all this? not necessarily. The way that I do programming and other people do programming as well is, just find a previous program that you have and just copy and paste it. Towards the end, I hope we get to this. There is actually some point-and-click interface where you can say, click on distributions, chi-square, and you can get it that way. Hopefully, we will get to that.
That's our commander.
Yeah, R commander. Yep. Okay, so lastly, then with the help, if you, let's say, know the function you're looking for, you can just simply type help pnorm at the prompt, and up will pop up the help window. But of course, you need to know what the function name is.
Otherwise, it gives you.
Yeah, sorry.
Help.
Help, and then
Help in the function name.
So you have to know exactly what they want.
Yeah. But if you don't know the name, of course, you can use the search engine and figure out what the name is that way. Okay, so that takes us then to page 14. One of the aspects of R that people like, especially when we first learn about it, and let me actually go there in my notes, is that R can perform calculations on vectors of information. What I mean by that is, suppose with the pnorm function, instead of just putting 1.96 in there, how about if I put negative 1.96 and 1.96? And since I have more than one thing, I need to combine them. So similar to what we did with earlier when we were combining the numbers 1, 2, 3, 4, 5, I use the C function. I combine them together, and look at R gives me both probabilities back. I could also do the same thing with the QT function. Quantile, T distribution, 0.025 quantile, 0.975 quantile. Let's say I want degrees of freedom of 9. Both will come back. I could put as many things I want to in there for that pnorm. It can be 2, it can be 10, it can be 20, and it automatically spits it back to you. So let's look at a little bit more complex example.
So the combine just means it's going to give you
Let me show you something. So let's look at, notice I'm just going to copy and paste a segment of this code into R, and we can see, well, what does that do? Well, it combines it into what in R's terminology is a vector. I call it a data set before just because it was easier, but it's actually a vector. It's a vector of numbers. And then when I combine this then with pnorm, it does both at the same time.
Can you combine vectors into another vector?
Yeah, so let's say suppose I have a vector y, and it has values of, let's say, 0.1, 0.2, and so on. I could say cx, comma y, and it combines it.
Makes another row.
What is the X? Where's the X?
X was what we actually created earlier.
1, 2, 3, 4, 5.
Yeah, the 1, 2, 3, 4, 5. Yeah, there's more efficient ways to combine data. This is not the primary way that we actually work with data sets in R, but it's helpful in quick little situations.
Basically just puts it together.
Yeah, yeah.
Is there also a way to make it a matrix? Like,
Yeah, and actually, I don't remember. I don't think I have this in the notes, but we can talk about this. So I can create. Let me actually save it. I'm going to call it temp gets a matrix, and the first argument is data. And let's say I just have 1, 2, 3, 4 in there, so I can create a 2 by 2 matrix. Number of rows equal 2, number of columns equal 2. Type temp, and there's my matrix. Okay. Now, since some of the stuff I'm going to do next, it will be tough for you to type in, since we haven't talked about how to actually, let's say, create a program yet. I'm just going to copy and paste it from my workshop document here. And let's say, for a little bit more complex example, we want a 95% confidence interval for a population mean. Very simple. And let's say I have a sample size of 10. I'm going to put my sample into an object called x. So I'm just going to copy, paste, and there's x. And if I want to find the sample mean, well, there's a function called mean. We already know about the standard deviation function, although we had written our one before. And let me go back here.
I assume if you have stuff in X already, it's now gone, still written, right?
Yeah, it's just overwritten. Yep, thank you. Let's say I want to find then the estimated standard deviation of the sample mean. Well, it's the variance of your data divided by n, or what R would use then, the length of n. So the length of this vector happens to be 10. So I'm going to copy and paste. So if I just show you length first, so there's that. Var of x and var.xbar. Now let's combine all these calculations then into finding our confidence interval. Let me just copy and paste and I'll explain. And there's my confidence interval. Okay, so look what I did here. I took the mean, I added something from the Qt function, quantile from a t distribution. But remember what that's going to do, corresponding to our example a few minutes ago, that actually has two numbers in it. The mean is how many numbers? Well, just one. It's one value. Also, square root of the variance, that's one number. So how does R know then, if I have two numbers here, and I'm going to multiply it using the asterisk, I'm going to multiply it by the square root of the estimated variance, how does R work? Well, it does what you want it to do, basically, you could say. It's going to take each number from that Qt and multiply it by this one number that's in the square root var x bar. Then you get to a point, well, so now I have these two numbers. What's going to happen when I add one number to it? Well, it does what you want it to do. It's going to take the mean plus the first number. It's going to take the mean plus the second number. So you can see that this potentially could save you a little bit of time. So otherwise, what I would have had to do was, just did one of these quantiles at a time. Oops. I would have just had to do one of these quantiles at a time to do my calculations. But imagine, let's say you have 100 values and you want to keep on adding one number to every value. Well, you can use the same idea to do those. Same thing with multiply. Same thing with more complex calculations as well. Okay. Now, there also happens to be a function in R called Ttest, as you might expect. And that not only will it do a hypothesis test for whatever you specify for the population mean, mu to be, at a specific level of confidence, it also calculates the confidence interval, and I get exactly the same thing as through my by-hand calculations, you could say. Okay. Any questions? Well, let's look at what are called packages. We've briefly looked at these packages before, the stat package in particular. Packages basically are just combinations of functions put into one, let's say, form. And one of the reasons why R has taken off is because anybody can write their own package and upload it to the R website, which is called the Comprehensive R Archive Network, or CRAN for short. There are over 3,000 packages that are available to you. So they might do some very basic stuff, but they might do more complex stuff. Often what happens in statistics now is that somebody, let's say, writes a paper on some new statistical method. Well, more frequently now, people just simply create the corresponding, let's say, implementation methods in R, put it all into a package, put it on CRAN, and then anybody can get to the research and can apply it immediately. Where before R existed, it was usually a lot more difficult to say, let's say you read a paper and say, oh yeah, that might work for my situation. Then you had to figure out, well, how do I program it and stuff? Well, now you can download it. And dissemination is very quick, you could say. Yeah.
Can we assume, or maybe assuming is the wrong word, given the detail orientation and scrutiny of the academic community that mostly uses this, that most of these are right? Or are we kind of user beware, sort of a combination of the two?
That is a very important thing, and that's one thing that people are a little concerned about. And we'll talk about it a little bit more later about, what's my amount of trust that I can have. Real briefly, stuff that's pre-built into R, yeah, you can trust that. Stuff that you have to, let's say, go to this website and download, well, it depends. If it's something that's been academically reviewed, well, that's going to be a lot more trustworthy than, let's say, some grad student who wants to get out of grad school and his professor said, write this package that puts your research in it. And again, there's over 3,000 packages out there. And remember, too, R started in 2000. So you can see how quickly packages that users have contributed have just made R grow so fast.
What's your experience? Most of them are reliable?
Most are, yeah. The CRAN itself does not, have a way to check, is that numerical value right when you upload it? But when you do submit something on CRAN, it does go through some checks, like do your examples run? And you're expected to put examples in there. So at least we know the code works. It just, you don't know necessarily if the calculations are correct.
It does what it says it's going to do, but it does work.
Yeah.
Is there some kind of review or feedback process so that if you're using it and it obviously doesn't work as it's advertised, you can provide feedback and comments on it?
Is that like sort of user groups?
Not on CRAN itself. I think there's something called SourceForge, which allows you to do that. I don't have a whole lot of experience with it, but definitely I think that's a good idea that inside of the R community itself to have, let's say on CRAN, to have something like that. But I think, and then again, we'll talk about this more too later on. We're talking about trustworthiness, and there are journals out there that now just specialize in, let's say, evaluating R packages. So let's say, for example, I'm an author of an R package, and so that I can get some credit at work for doing this, of course, in my profession, I need to write a paper. So I submitted a paper on it to the R journal. It was published about a year ago. And so, there's going to be a couple referees that are going to, look into my code and stuff like that. And as long as they did their job, and I'm pretty sure that everything that I did was correct too. It's a lot more trustworthy than the dissertation example that I told you. Okay, so there's tons and tons of packages out there, and in fact, there's so many, it's even become almost a little bit unmanageable. And this is a recognized problem to some respect by the R community. And there's been some small advances to make it a little bit better. But let's look at how we can actually install one of these user-contributed packages. So what I'd like you to do in R, go under Packages and Install Packages. Now this might be the one place if you don't have, let's say, administrative rights to your computer that this might not work. So Install Packages. And then you see a list of all these places around the world that have all these 3,000 plus packages available for you to download. The closest one to us is at Iowa State, USAIA. You can pick that one, or you can pick another one. It doesn't matter.
Why do you have to go to the closest? What does that mean?
Well, I'm thinking that the speed of light that everything's traveling from Iowa State is going to be faster than from, let's say, maybe Taiwan. So, but in the end, it's not going to be that big of a deal.
There's mirrors of all the same things.
Yeah, yeah.
They're all the same.
So pick one, click OK, and here come this 3,000 packages.
Okay.
And you can see it's kind of hard to find one particular package in this list. Yeah, and what made it even more confusing in the past is that you see some the first letter there. You see a lowercase a, uppercase a. Well, R would actually sort those out so that uppercase or lowercase, one of the two, would be first, and then lowercase would be second. And it just made it a pain. Fortunately, now they've integrated it all into one. A means A.
I wonder if this is like the Yellow Pages advertising strategy, like A.
Yeah, that's a good idea. Yeah, the next package I write is going to be, quadruple A. So if you try to find something called ODBC. No. Yeah. This is a package that's going to allow us to read in Excel files later. So output, I think it's output database connectivity. That's ODBC. Open, thank you. Yeah. So you click on OK, and it downloads and installs. I was worried that all of us would be downloading this something and we might clog up the network, but it's not that big of a file. You see 732K. So.
It's asking me, would you like to create a personal library?
It doesn't matter. You can say yes or no. It's kind of saying, well, do you want others to be able to access it?
Oh, it takes into the same.
We want to download something backdoor through our firewall through our. I'm not listening.
So now, once we downloaded this package, does it stay, or do we download it again later?
It stays on your computer. It stays on your computer. If, though, you update to a newer version of R, you'll need to download it again, and that's one thing I don't like. But these packages are updated a lot, so maybe it's good to do. Right now, there's what's called a core group of R people. It's about 20 people that control some of the basic aspects of what R is, and they have recently announced that the update schedule is going to be now about once a year in terms of, I'm sorry, not update, but a new version schedule is going to be about once a year. In the past, it was about every 6 months. So version 2.14.0 is going to come out in October. And then, I guess, then the next year they'll go to this new version schedule. So this remains on your computer. You never need to do this again unless you install a new version of R. However, if you want to use the functions that are in it, anytime that you open up R, you need to type this: library package equal RODBC. And that tells R, okay, now I can start using those functions. I have access to them.
Case sensitive.
Yeah. Thank you for bringing that up. It's in the notes, but I forgot to mention R is case sensitive, so please be careful. Yeah, at first that can get can be a pain to get used to that if you're not used to a case sensitive environment.
Is somewhat helpful in telling you what your error might be when you make an error?
Exactly. Yeah, there is. There's a variety of things. One thing we'll hope to get to a little bit later. There's something called Traceback, and there's no Traceback available because everything's okay. There is other debug packages. I don't have experience with them, but there are options available. Okay. So let's see. So that's a package, and there's lots of packages out there. If you want to, we can do this. Notice that there's a small error in the notes on page 18. I forgot to insert a hyphen between R and project.
Page 18.
Yeah, page 18.
So it should be
R hyphen project. And I'm just going to go to that link real quick. Here's where you can access all the different all the different packages if you wanted to see them listed on the actual CRAN website. And notice they have sorted by date of publication, sorted by name. And what I have found then, the best way, and you can do this on your own too. Why don't we do that? I think this is going to be helpful. If you go to, I recommend going to that, well, you can't see it very well. If you go to cran.r-project.org, you will get to the main website for R.
There's the R journal.
Yeah. Okay, so on the left-hand side, you see packages. Click on packages. Then you see table of available packages sorted by name. And there's a variety of ways that you can find a package of interest. Why don't we do this? Why don't you do a search on the web page? So like if I'm in Internet Explorer, I can go to this little drop-down box and do find on this page. And, I don't know, pick your favorite statistical method. So I do research in an area called group testing. So I'm going to type that, and then I'm going to click Next. And it takes a little bit because there's 3,000 packages listed in this web page. And it comes to, eventually, it finds something called the GT Core package to do some group testing. What? Excuse me?
We don't see the find window.
When you hit Control F. Control select F.
So you can enter what you want.
Pick your favorite statistical method, short name. Maybe if you type regression, for example, you'll see packages that deal with regression. I deal with group testing research, or I do stuff in group testing. And so there's a package called GT Core, which corresponds to a paper that was recently submitted to biometrics by someone else, not me, that I reviewed. If I click to there's two matches, so if I click to the next one, we come to my actual package that I've created called bin group. So, I don't know, maybe you do some stuff with Markov chain Monte Carlo MCMC. So if I type MCMC, you're going to see there's 22 matches. So there's 22 packages out there that do something with MCMC. And so that's a kind of a quick way. If you don't know what you're looking for necessarily in terms of the actual package name, this is a quick way to find something. Any questions? Okay. So then that takes us to page 19. So this is actually where I give the R is case sensitive mention. Now, what can you use for an object name? I've used simple names like X, save. You can use pretty much what you want in terms of characters and numbers, although don't start with a number for the name. And often, you want to maybe, let's say, combine multiple words into an object name. Well, the way that people typically do is use a period or an underscore. Those are legal. So the way that somebody would pronounce this mod period fit, which is a shorthand word for model fit, people would say this as mod.fit. They wouldn't say mod period fit for it. That's the way most R users refer to it. Again, you could use an underscore as well. Up until probably about 2005, underscores were another way to do those assignments. So the less than dash was actually, you could also have done an underscore. And so then they made the switch. This is when they went from basically R version 1 point something to R version 2.0. I was always an underscore person to make the assignment, so I had to change all my code. It was a pain. But I got used to it. And one thing then they eventually then added in other versions of R past 2.0 is that now you can use an equal sign to make the assignment. So we could have said, let's say, x equal C parentheses 1, 2, 3, 4, 5. We can do that. But still, since less than dash was always so prominently used for S, S plus, and now R, most people still use less than dash. But equal will work. It's, equals one less keystroke. So page 20. So it's nice to be able to type something in R console and have it immediately evaluated. But at times, you're going to have, let's say, a long set of commands that you want to actually execute. And it's going to be a pain to actually have to type it line by line by line by line. So what you would want to do is create a program that basically is some kind of text file that contains your commands. And then you can run it. And one of the early problems with R was there was no built-in program editor. It wasn't until 2.0, which came about in like 2004 or 2005, that there was actually a program editor. So we are not going to use this program editor, but I do want to point it out to you. You can do this as well. If you click on File, New Script, you hear programs called scripts in R, but most people I know call it programs. So, that's what's often called. And up will pop up the R program editor. This is a very, very, very basic editor. If I wanted to, I can type some of the stuff like what we did before. So I'm going to type x gets. You can do this if you want. X gets a vector 1, 2, 3, 4, 5. And I'm going to use SD parentheses x and parentheses. If I want to run that code, one way is to highlight it, come up here to edit, run line or selection, and what will happen is that the code is then transferred to the R console window. I can also run all as well. I can save the file, save the program if I wanted to. And notice the extension on the file, .r. It doesn't matter if you use uppercase or lowercase r. So that's a very simple program editor. There are many, many, many better editors out there. And one of them is called Tin. And I think before we get into Tin, why don't we change gears here and go to this extra information file, and we'll cover some stuff on this and then take a break. So turn to page 3, please, in the extra information on R file. Okay. So what I have here is, in this file is just, or this document, is just a bunch of useful things for R. And the first part here is this web resources for R. One nice resource is if you go to chrisbeller.com/resources. I guess if you really wanted to, you could open up the file and click on some of these links. You don't need to, but it's up to you. So you can open up the PDF corresponding to this. And if on the right-hand side, after I page down, you see all these R links. So, for example, packages written by users. Notice that's in black because that's where we were earlier. You can download R from there. Some information about reading in Excel files. A whole bunch of useful stuff. Let's see. Oops, wrong file. Okay. Now, the primary way that people try to get help externally when they use R is to go to the R listserv. This is a fairly active listserv. There's about 100 posts per day of people with questions and then people responding to those questions. Often, the R core group members, those 20 people that control the central part of what R is, they will answer your question. So that's really nice. So you can post a question, and somebody hopefully will respond. Usually they do. But before you do that, make sure that somebody else hasn't already asked that question. Because if you ask the exact same question that's been asked 20 times before, you might have an R core person reply to your message in a not nice way. That's never happened to me, but I've seen that happen on the R listserv. And so what you need to do first is to go to the archives. And so I have a link in this document for the archives. You can go to it if you want to. It's not the easiest thing. I guess it probably would be best if you had the PDF file corresponding to this open. Why don't we do that? So when you were on my website, you downloaded this extra information on rfinal.pdf. It was also in the .zip file. If you want, you can go to that file and you can, of course I keep on going to the wrong window, you can click on this link and it takes you to the archive. Okay. And so we have a nice little search engine that you can use to find stuff. Notice what's given as the target. Basically what's given by default, without going into all those details, is the help web pages that we've looked at previously. To actually search the archive of past questions on the listserv, I go to rhelp 2008 to 2009, 2010 on, and 2002 to 2007. So from 2002 on, I'm going to search all the R listserv archives. And how about if I just simply type my last name to see what pops up? Instead, you could type like a statistical method if you want to. Type a function name. And what will pop up is a question that I posted. Not actually 2009. I don't know why that's there. It was back probably about 2006 or so. You see a question that I posted. And let me open it. And so I was trying to figure out something with the bootstrap. That's my question. If I page back, we have two responses. Brian Ripley, who's a member of the R core, responds and tells me what to do. He's one of the people who can sometimes give you a not nice response if somebody else has already asked that question. So I was like, oh, great, he's responding, but and he did it in a nice way. So this can be useful. Some other stuff. If you want to actually subscribe to the listserv, there's a link that you can follow. Again, about 100 posts or more per day. So if you subscribe to it, you're going to have your inbox is going to be filled rather quickly. So what I recommend is to subscribe in digest mode, and then you'll just get one per day that has everything summarized in it. To be honest, though, I still subscribe to the rhelp listserv. I don't really read it that much anymore. More so due to time, but also because I found a little bit better way to read the listserv as needed. And there's probably other ways to do this as well. This is a nice little web page that basically summarizes everything in a nice a threaded content manner, and you can see stuff a lot better. There's also a nice another help mechanism that's been developing now over the last couple of years. There's a website called stackoverflow.com, and it gives it's basically a website for questions and answers for various programming languages, and R happens to be one of them that is listed there. And so, it gives you a question, and then people can respond to it. So it's just a different way to find the answer to something that you might have a question about. Okay, so that was the first part of web resources for R. I think I said originally that we would take a break about 10 o'clock. The next thing that we're going to do with TinR might take more than 5 minutes, so why don't we simply take a break right now. And let's get back around 10:10, 10:15, right around there.